Assalamu alaikum warahmatullahi wabarakatuh. You are welcome to physics class today. We want to continue our discussion on graphs of uniform motion, and this is known as part 2 of what we have discussed earlier. Now, first discussion, we have looked at how we can interpret graphs of motion that has been drawn. In this case, we are going to learn how to draw the graph ourselves and then interpret it. So the objectives of this lesson: one, we should be able to sketch the graph of uniform motion, and we should not forget that we have talked about two types of motion, uniform and non-uniform motion, and we have learned that for uniform motion we have straight line graphs, and non-uniform motion we have non-straight line graph, we have curved line graphs. Okay, and also we are going to be able to interpret the graph that we have sketched and use it to find acceleration, retardation, distance traveled, and average speed in a given journey. All right, going to the discussion, we have a problem here that says a car starts from rest and accelerates uniformly until it reaches a velocity of 30 meters per second after 5 seconds. It travels with the uniform velocity for 15 seconds and then brought to rest in 10 seconds with a uniform retardation. So we have the following questions. Draw a graph of the motion. Use the graph to determine the 1. Acceleration, 2. retardation, 3. distance traveled after 5 seconds, 4. total distance traveled, 5. average speed of the car. So let's start the first part, which is to draw the graph of the motion. To draw a graph, you need the vertical and the horizontal axis labeled, velocity meter per seconds, time in seconds, and this is the origin. So if a car should start from rest, so the graph drawing starts from here. So a car starts from rest, travels, accelerates uniformly until it reaches velocity of 30 meters per second. So it starts from here and goes, and let's say stop here. It can be anywhere. Let's stop there. So here we have 30 meters per second on the vertical axis, and the time that's taken for that is 5 seconds on the horizontal axis. So it maintains this uniform velocity for the next 15 seconds. Okay, so that will be a straight line. A straight line goes there in the next 15 seconds, but we are not going to write 15 seconds there. So we are going to add 15 to 5, and that will give us 20. So this is the time for the uniform journey, uniform motion, uniform velocity of the journey. Then it is brought to rest after 10 seconds. So it is coming down to rest after 10 seconds. So when 10 is added to 20, the time for that is going to be 30. So you should understand how to write your time on the horizontal axis. It started with 5 seconds. The next 15 seconds, add 15 to this will give you 20. The next 10 seconds, add 10 to 20 to give you 30. All right, we have drawn that. So this is the graph of this particular motion. So let's now use this graph to answer the following question. We want to find acceleration. Don't forget that this part of the journey is acceleration, this part is uniform velocity or speed, and this part is retardation. Okay, now we know that if you want to calculate your acceleration, you are going to use change in the acceleration here is going to be change in the vertical over change in the horizontal. So a body started from here and accelerate to this point. So if you are reading it on the vertical axis, this is the initial velocity and this is the final velocity, and on that it is final minus initial. So final velocity is 30 minus initial 0 over in time. This is the initial time on the horizontal. This is the final time on the horizontal. That will be t final minus t initial. That will be 5 minus 0, and if that is computed, you have 6 meters per second squared. Now to calculate the retardation, this part is retardation. Okay, and it means that the body retarded like this, and this is the starting point of retardation, and this is the ending point of retardation. So if this is going to be your initial velocity on the vertical 30, and the final velocity on the vertical is 0, and it will be 0 minus 30 because it is final minus initial. That will be 0 minus 30. And coming to time, this is the initial time 20, and this is the final time 30. Final time minus initial time, that will be 30 minus 20, and that will give you 10. And if that is computed, you have minus 3 meter per second square. This minus sign is just showing that the body is retarding, and this is showing that the body is accelerating. Okay, now going to the distance traveled in the after 5 seconds. Is not distance traveled in the whole journey. The distance traveled after 5 seconds. So you have to look at the shape under after 5 seconds. Shape there is triangle. So it's going to be area of triangle. Shape that distance traveled after 5 seconds will be area of triangle, and that will be half times base times height, and your height is on the vertical 30 and the horizontal your base is 5. So we have times 30 times 5, and that will give you 35 meter. All right, the next question says calculate total distance traveled. So it is now you look at the whole shape of the graph. The total shape under the graph is trapezium. So in this case, you've used area of trapezium to get the total distance traveled, and that will be half times sum of the parallel sides times height. So half times sum of parallel side, this line and this line are the parallel sides. So this line I used to call it AB. So the time at B is 20, the time as A is 5. So 20 minus 5, that will give you 15. That's how I got the first line 15. And on the other line, this from this point O to this point 0 to this point 30 is the other parallel line. That will be 30 minus 0, and that will give you 30. And the height is 30. That will be half times open bracket 15 plus 30, close the bracket times 30, and the answer there. You can see I label it AB, and that is going to be giving you 675 meter. That is the unit for total distance traveled. Then to calculate the average speed is total distance over total time. Total distance is 675 meter over total time on the horizontal is 30, and that will be 375 over 30, which is going to be 22.5 meter per second square. So please let me quickly add more points here. The average, the horizontal, the parallel lines here are A, B, and OC. Add them together. So AB is 20 minus 5, that will give you 15. That's why I got 15 here. Then OC is 30 minus 0, and that will give me 30. So that's how I got this one. So please, sorry for taking you back. Another question coming from NECO 2018 question 12C. We have that a car travels eastward at 20 meters per second for 40 seconds, and then accelerates at 14 meters per second square for 20 seconds. So sketch the velocity time graph of the motion, and then use the graph to find the final velocity and total distance covered. So in this case, we always draw the vertical and the horizontal axis labeled velocity in meter per second, then time in seconds. So a car starts from in this case, this body is not starting from rest. If it was to be starting from rest, we would have started our graph from this point. But the car is starting eastward 20 meters per second. So let's just pick any point here on this axis to be at 20 meters per second and draw. And then they said travel for this, it travels uniformly. So from that point, we just go on a straight line. It's a uniform motion. A car travels eastward. Even eastward is standing for uniformly. So it's eastward. From this point, it goes this way. And for 40 seconds. So bring it down. So that is 20 seconds, and the time is for that journey is 40 seconds. 20 meters per second for 40 seconds. So they now added that. Then accelerate at 40 meters per second. So it's from this point, it started to accelerate. Goes up like that. So for 40 meters per second for 20 seconds. So that time here, the time for this acceleration should be 20, And when it gets there, just add 20 to 40. So this place can be 60. So this place is 60. If I add 20 to 40, we'll have 60. And then this is the graph. You have drawn the graph, but what is missing is this V. You don't know the velocity, the final velocity at this point, but you have been given the acceleration that led to this velocity. So what we need to do here is to calculate the acceleration first, then to calculate the velocity here. And question even requires us to use the graph to calculate the final velocity. So we want to know the velocity at this point. So I should have put V here. Maybe I'll put it in the next slide. V to show is the final velocity. Right. Now, I can see it. I have the V there. Right. I want to calculate this V. So to get this V, I'm going to say acceleration is change in velocity by change in time. So my change in velocity, acceleration, body started to accelerate from here to here. So this is my final velocity, 20, and this is my initial velocity, 20, and this is my final velocity, V. So that is going to be my acceleration is A given to me equals V minus 20, which is final minus initial, over the final time, 60 minus initial time, 40. So with this, I can get my V by making use of the formula, and V is going to be 300 meter per second. So my final velocity is 300 meter per second. So all you need to do is to know your acceleration, and the formula for acceleration is change velocity by change in time. You should know that this is my initial velocity and this is my final velocity, and that will be final minus initial, that is V minus 20 over the change in time. What is started from here? The initial time is 40, and I ended the final time is 60. So 40 minus 60, that will give me 20. And from there, if I make V solid formula, I'll have V to be equals to 300 meter per second, which is my final velocity. Now, to calculate the total distance traveled, I'll have to label the shapes. I cannot give this one a complete, I can't name it directly. So I have to break it into shapes. So I have shape A and shape B. So this one is not considered. This is not shape. Wow, I'm only using this line. It's a broken line. It's not part of the journey. So I have shape A and shape B. Shape A is a rectangle. Shape B is trapezium. So I'm going to look for area of rectangle plus area of trapezium. So area of triangle is half times base times. Area of rectangle is half is length times breadth, while area of trapezium is half times sum of parallel sides times height. So for the A, the length is 40 and the breadth is 20. That will be 40 times 20 plus into bracket half times base times height. Plus half times sum of parallel sides. So I have this to be my parallel sides. My first side is 20. I will read on the vertical. This side is 20 and this side is 300. So that will be 20 plus 300, because my initial velocity here is standing for my first line, and the final velocity here is standing for the second line. So I'll have it to be 20 plus 300 times height. The height is here. That will be 460 minus 40. I have this place to be my height. So that is going to be this one will be 40 times 20 will give me 800. Half times 320 times 20 will give me 3. Half times 320 times 20 will give me 3,200. And if these two are added, we have 4,000 meters, which is the distance traveled. So we are asked to sketch and calculate total distance traveled, which we have done. So we've answered our question. Now going to a third question here. We have that a body at rest is given an initial uniform acceleration of 60 meters per second square for 20 seconds, after which the acceleration is reduced to 4 meters per second square for the next 10 seconds. The body maintains the speed attained for 30 seconds. So they have to draw the velocity and graph of the motion and use the information to calculate the maximum speed. Calculate the maximum speed attained during the motion, and B, total distance traveled during the first 30 seconds, and finally C, average speed during the same time interval in B above. This is coming from Y. Alright, so as usual, we are going to draw the vertical and the horizontal axis labeled. Then a body at rest, we should know that the body is starting from here. So it was given an acceleration of 6 meters per second uniformly. We have this to be my first acceleration, and let's label that if A1 will give me V1, and the time for that is 20 seconds. So I'm going to calculate my V1 later. I've known my A1 and the time, so I will be able to calculate V1. But let me go on. We have again that after which acceleration is reduced. Now, if it is reduced to 4 meters per second, this is what we are going to have. It's going to bend down. If it was to be increasing, it will bend this way. It will bend up. It will go up from here to bend up. But from here, it is bending down because it is reduced to 4 meters per second square for the next 10 seconds. So I'll add 10 to 20. That will be 30. So that is 30 seconds. And A2 is going to produce V2. Okay. The body maintained the speed for the next 30 seconds. So we have a horizontal line there. The body is going to maintain the speed for the next 30 seconds. 30 plus 60, that will give 30 plus 30, excuse me, that will give me 60. So I have sketched the graph required for this velocity time graph required for this motion. Now from the graph, let's now start to calculate. We have to calculate we have to calculate the maximum speed attained. So we are looking for V2. That is the question. We're looking for V2. But to get V2, A1, velocity acceleration is velocity over time, or change velocity over change in time. So if I cross multiply here, I will have my velocity to be equals to AT, acceleration times time. So if I want to get my V1 is going to be A1 times T1. So A1 is 6 meters per second square, and T1 is 20 seconds. So if I do that, I will have 6 times 20. So I just have to multiply 6 by 20, and that will give me 120 meters per second. That is my velocity. That's my first velocity. So if I want to get my V2, I may not be able to use this formula directly. I will have to use another formula that says A2 is going to be change in velocity over change in time. Change velocity, that will be V2 minus V1 over T2 minus T1. So my V2 is unknown, my V1 is 120, my T2 is 20, my T2 is 30, and my T1 is 20 if you are considering this journey. So if I substitute, I'll have my A2 is 4. So that will be 4 equals V2 minus 120 over 30 minus 20. And if that is solved, making V2 subject to the formula, about V2 equals to 160 meters per second. So I've calculated the maximum velocity reached. Okay, the next question is asking to calculate total distance traveled in the first 30 seconds. So I'm going to look at the shape on that first 30 seconds. This is the first 20, first 30. So I have shape A and shape B, and that will be area of shape A plus area of shape B. A is triangle, B is trapezium, just like the former one we solved, right? So area of triangle plus area of trapezium. So, and that will be half times base times height plus half times sum of parallel sides times height. So half times base for triangle, base is 20, height is V1. Now V1 is 120. So half times 20 times 120 plus the sum of half times sum of parallel side. This is the first side, V1 120, plus the other side, which is V2, and that is 160 times height. Height is 30 minus 20, that will give me 10. So if I multiply, if I operate that, I'm going to have this to be 120 and this bracket to be 140. If added together, I have my total distance traveled in the first 30 seconds to be 2,600 meters. So calculating the average speed. Average speed is total distance traveled over total time. Total distance traveled is 2,600 over total time for that same journey is 30, and that will give me 86.7 meters per second. Thank you so much for your audience. I want to believe that this video will have helped a lot concerning how to draw graphs, how to interpret the graphs, and how to use the graph to solve problems. I would like you to subscribe to my YouTube channels for more videos. Assalamu alaikum warahmatullahi wabarakatuh.